Hello everyone, myself Dr. Sriparna Saha, and on my YouTube channel we used to discuss about different topics, whether they are from the theoretical ones or it could be from the coding aspect as well. Today we are going to talk about the artificial intelligence. These many videos are already present over there. If you haven't studied them, please do so. Today it's about the part 2 of problem solving. Right. Today we are going to talk about the well-defined problems and solutions in a more detailed fashion. So, the well-defined problems and solutions. What are the components? We have already discussed in the last class. That is the initial state, actions, transition model, goal test and path cost. These are the components. 5 different components are present in the well-defined problems and the solutions. And this figure, I have already told that this figure has been taken from the book by the Russell and Norvig. The book name is Artificial Intelligence. And that book by Russell and Norvig, you can check that we are traveling from a city called Arad to Bucharest in a country, Romania. So what is the initial state we are currently in? That is, the agent starts from the Arad city. Now, what are the different set of possible actions it could be? That is, Arad is the current state, next state is CBU. Next, the next state can be Fargaras, and the next is the Bucharest, and Bucharest is our goal state. So we have reached the goal. These are the set of possible actions could be. Now, the transition model. That is basically the description of what each node does. Here we need to mention the successor functions. Those are going to refer to any state reachable from given state by a single action. Initial state, actions and transition model define the state space. That is the set of all states reachable from the initial state by any sequence of actions. Now the goal test, we need to test whether we have already reached the goal. If we have already reached the goal, our work is done over there, right? As this type of problem solving are for the goal based agent. So the goal test, that is basically applied to current state to test if the agent is in its goal or not. Sometimes there are explicit way of defining it, that is the example in Arad, and the implicit way, that is the chase, that is in the checkmate. If the agent wins if it can capture the king of the opponent on next move, that is the checkmate, then it is the implicit way of representing the goal test, and it is no matter how what the opponent does. To get the better or the more idea about this goal test, you can refer to this video, that is the problem solving part 1 video. Now just come over here. So this is the goal test. Now what about the path cost? So path cost is a function that assigns a numeric cost to each path. This is done to measure the performance, and sometimes it could be denoted by the value g, that is small g, and it is used to distinguish the best path from others. Usually the path cost is the sum of the step cost of the individual actions in the action list. This is the path cost, and the better idea of the path cost is also given in the first lecture of this problem solving, right? Next, after the path cost, this is the 5 components we have already defined for the well-defined problems and the solution. So the solution of the problem is then the path from the initial state to a state satisfying the goal test, and the optimal solution is the solution with the lowest path cost among all the other solutions. That will be your optimal solution. Now we have already told these type of things we are going to do by the search tree approach. Just check over here. This is the search tree, and each search tree there will be different nodes, and each of the node you need to search, and based on that you need to expand to your child node, and this is your search strategy, right? So if you have already represented the search tree, then you can come over here this particular thing, that is the fringe. So fringe are the set of search nodes that have not been expanded yet, that is the nodes you haven't checked yet, right? It is implemented as a queue, that is insert node comma fringe. That means whatever be the first node over here, that will be executed first. What is queue? Queue is suppose in a bus line, so it's in the queue. The first person who has come to board the bus will be boarded first in the bus, that is the queue. The last person came, that need to wait for all the other passengers to board the bus. That is how fringe works, and a queue principle. And if one particular node you need to remove, you need to write this remove fringe, right? And this is the ordering of nodes in fringe that defines the search strategy, right? How the nodes will be ordered, based on that your search strategy has been defined, whether it's a breadth first search or a depth first search, that depends on the ordering of the nodes in the fringe. Now the search algorithm. This is a generalized search algorithm. First you need to check whether you have reached the goal state. It could be that your initial state is your goal state, right? Then you do not need to go forward, so you need to check whether your initial state is a goal state or not. If yes, then return initial state. If not, you need to search for the child nodes, that is basically insertion of the fringe nodes, that is the nodes that haven't been traversed so far. So that is insert function you need. Insert initial node comma fringe, that means the nodes, that the child nodes of the initial state, that will be given there. Now this total process need to be repeated. How much amount of time? Until the fringe is empty, then return failure, that you have executed all the nodes but none of the node is your goal node, so you have failed, your algorithm has been failed, you need to return failure. If not, then one particular node need to be removed from the fringe, and that node becomes your state, right? And for each of the state you need to check for its successors, that is its children nodes, and for each particular state, suppose S bar, it has a successors, then you need to create another node for each of the successor and check whether that successor is your goal node, yes or no. If that successor is your goal node, fine, you have reached your goal. If not, you need to move to its child node, that is a child and of child node, and then you need to return the path or the goal state when you have reached the goal. And if you haven't reached the goal, you need to insert the child nodes into the fringe. This is all about any general search algorithm. So this is the example of the search tree. This figure is also taken from the book by Russell and Norvig. Here you can see, that is if suppose you are in this particular state, that is the Arad. So this Arad. From Arad, how many cities you can go? You can go to 3 cities, Sibiu, Timisoara and Zerin. So just see, there are 3 possible child nodes for the mother node Arad, right? From Sibiu, you can go to 1 and 2, then 3 and 4. 4 possible child could be, that is from Sibiu, you can again go to Arad, that you are not going to go, but you can go. Then this particular, this and this, that is 4 child node. Then Timisoara. Timisoara is present over here, right? So that is this and this, 2 child. Then Jerin, it has another 2 child. So this is the search tree. Now if you are in Arad, you can go to any of the 3 child, right? Now suppose you have already moved to the Sibiu child. From the Sibiu child, you can go any of the 4 child. So this is how search tree algorithm works, and the details of the search tree, that will be on the next lecture. Until now, you can please subscribe to my channel, and happy studying.